You know, here. Let's see. Just had an epiphany. We'll try something real quick. All right, we only got 20 people logged in. Let me do one other thing, and then we're gonna start. If y'all who are here in person, go ahead and if you log into the app, you can follow the notes. But last time I tried to put the camera facing the board, and it was cracking. So I'll just annotate the screen, and then that way you'll have, and I'll upload the notes to our Blackboard. Can y'all see it? You see it? All right, you got it? Okay. All right. So today, which is the 14th, and first let me say that it's good to actually be in person. I know we had a bunch of hiccups. But today we're doing aspirin synthesis. All right, and for those of you who are logged in, can you hear me? Okay.
Yes.
Yes, I can hear you.
All right.
Yes.
So we're doing aspirin, synthesis. And it's a very simple experiment. Couple of techniques involved. We're going to learn about using a steam valve. Somebody here. We're going to learn about that. We're going to learn about vacuum filtration. We're going to learn about different measurements, and the most important thing, how to set up a synthesis. All right. So with this aspirin synthesis, if you downloaded the data sheet, the reaction scheme is up top, right? We're going to take, and you should have filled out, if you haven't already, you'll have time today, but you should have filled out the reagent table. And we're going to actually look this up even before we start. So we're going to take salicylic acid, which looks like this. And for those of you taking part one, right, again, you can never get away from these functional groups, right? That's the carboxylic acid, an alcohol, and an aromatic. And we're going to take that and we're going to do what the type of reaction with the aspirin synthesis is. It's called an acylation. Let me. Right, this is called an acylation reaction, and I'm going to show you why. All right, so we're going to take salicylic acid and we're going to react that with acetic anhydride, which looks like this. All right, this is a type of ester. You can see that the ester functional group right there. And so with that acetic anhydride, this group that's attached here is going to end up on your alcohol, right? So that group that I have highlighted in red from the anhydride, it's called an acyl group. So that's why we call it an acylation. All right, we're going to take that group and attach it. The overall reaction, the acylation reaction, is a type of esterification or synthesis of an ester. That's what we're doing. All right. So aspirin itself is a type of ester, right? It's got multiple functional groups. One of them is the carboxylic acid. The other is going to be an ester. So when we put these two together, hopefully you had a chance to watch the aspirin video. So I'm not going to go through the mechanism here because I really want to just get cracking on the experiment. So when you put these two together, what you end up with is aspirin, which is here. The carboxylic acid doesn't get touched. And then you have O. Let me do something real quick, change the color on that. Right. So this is aspirin or acetyl. Go ahead and mute salicylic acid. All right, so acetyl salicylic acid. And then one of the leftover products is acetic acid. So it's this HO. So that's left over from here. It's this piece that's, well, not that, it's this actually this piece. All right. So we're doing the reaction in the presence of sulfuric acid. Fix my arrow. So sulfuric acid, H2SO4, deadly stuff, but we're only using a catalytic amount. And we're heating this up. So we're going to use a water bath. Right. So while we're doing this reaction, what you're going to find out is that as you heat those reagents, the solution, the salicylic acid is a solid, acetic anhydride is a liquid. When you heat them together, and we're doing it neat with no solvent, when you heat those two together, eventually, when the esterification happens, that solution is going to go clear. So all the solid is going to dissolve and be absorbed by in solution. And then once you get that, once it goes clear, then you're going to continue to heat for an additional 5 minutes. After that, you're going to take it off, let it cool to room temperature, put it on an ice bath, and then filter it. So I'm going to put the steps down here. So the steps for the synthesis, first step is to weigh out salicylic acid. Should have brought a stylus. No, I'm good. Add acetic anhydride. I'm just going to abbreviate that. And sulfuric acid. Sulfuric acid is your catalyst. We're only going to add a few drops. I think the procedure calls for 6 to 8 drops. All right, and that's just going to facilitate this, the acyl part of that acetic anhydride is going to activate it. Right, if you watch the video, you saw the activation part where you just do a proton transfer with this oxygen right here. So that's going to get protonated by sulfuric acid. It's going to make the carbonyl more reactive. And then the oxygen from the salicylic acid is going to attack it. All right, so we're going to add acetic anhydride and sulfuric acid, and then we're going to heat. Sorry. Right, heat until the solution is clear. And then when it goes clear, I'm going to heat for an additional 5 minutes. Right, and that's it. And after that, we're going to filter it. So one of the things about this experiment is that sometimes one of the pitfalls that happens every semester is sometimes you won't have your water bath won't be hot enough. If your aspirin happens to go solid, then all you have to do is just heat it for a longer period of time. But if you heat it and then it cools down some, it's going to go solid. So for those of us who are here, we're going to make sure that we keep it immersed in the water bath at all times and keep moving it. Keep swirling it to make sure that that it doesn't go solid on it. That's the only misstep that happens with this part. Then when the next time we come back, we're going to do the purification, but it has to sit for a week to dry before we can do that. So we're going to get started, and I'm going to take these notes and email them to myself real quick so I can post them to Blackboard. And then that's the beauty of having your own hotspot. You don't have to be fooled up with Golden Tiger Connect or whatever it is. Let me get back to Zoom, turn my camera on so we can start moving. All right, so the first thing we're going to do, I'm going to turn this camera off on this one. I just need the audio. And we go through to teach hybrid labs. All right, let me stop sharing and pin this. All right. Got the camera on. All right. So what we're going to do first is weigh out the aspirin. I know what it called for in the procedure was 13.9 or 13.8 grams. We're going to cut everything in half. So it's going to be 6.9 grams of salicylic acid, and it's going to be 7 milliliters of acetic anhydride. So those of you who are streaming, you can do now is go ahead and look up the values for the reagent table. So go ahead and look up the density of acetic anhydride. Go ahead and look up the molecular weight for both acetic anhydride and salicylic acid. And don't worry anything about the sulfuric acid, because it's catalytic. So we don't care about the molecular weight or the moles, because it's not enough to participate in the reaction. It's only catalytic. So we only want to add enough to catalyze the reaction. So not to worry about that. But go ahead and look those other values up so you can have them in the table, because one of the other things about the reaction that you're going to need is the moles. So you need moles of salicylic acid, moles of acetic anhydride, so you can figure out the theoretical yield. All right, so you need everything in moles. For acetic anhydride, you get the density, and then you take the amount that we add in milliliters and use the density to convert it into grams, and then grams to convert into moles. And if that's befuddling, I'll share the screen and go through it. But right now, we're going to go ahead and get started. So I'm going to move the camera over here. Where we're going first, to weigh stuff out. Have that. So we're going to weigh everything out on a piece of wax paper. And before we do that, go ahead and grab some gloves. So, I don't want anybody going home with acid burns or salicylic acid, it making you itch. Even though that it is a skin product, they use it a lot for acne and things like that. I got medium breast, so that's it. Oh, you just have to stretch them out. I like the tighter ones better.
Oh yeah,
Work
facts,
better.
facts.
Those large and extra large and all, they all floppy stuff will get in there. We don't want that. All right, so everybody go to the back. I want you to grab a hot plate off the cart and also a big beaker, a 600 ml beaker, and put some water in it from the faucet. Let me turn the water on so we can get the brown stuff out of it. But you know it's gonna be brown because we haven't been over here in a while. So for those of you who are streaming, again, I'll show you the setup once we get it set up. But we need a hot plate because we can't heat a water bath up without a hot plate. And then we need a 600 ml beaker. That's going to be the vessel for the water bath. And then we're going to use a 125 milliliter early mark flask to do the reaction here. So it's very simple setup. Don't plug it in there. Oh, no, go ahead. You're right. I thought you were plugging it into the box.
Oh.
Yeah, that's a transformer, so you don't want to use that. I'm paranoid. That's like a common mistake. So
I can hear it.
yeah.
I have a limited range of motion in my arm.
Okay.
So
Let's see, that's a 600. Fill it up to about 200. Yeah, fill about 200. Because what you want to do is you don't want it to be so much that it takes forever to heat up. And you also want to be able to sit your flask down in there and it not be over. Right? It doesn't spill over. All right, so what we're going to do now, we got the setup. We're going to go ahead and weigh out the salicylic acid. And again, we're just going to weigh this out on wax paper to make sure that's all the perfect. All right. Let me get the flash. First, anybody now? Might as well. Well, sure now. So everybody who's streaming, you've taken CHEM, I'm sure if you paid attention. You know that you don't weigh anything out without first tearing out the balance, right? So you just hit the filter paper on there, and you can see the balance is very sensitive, even the small movements. So that's why normally you'll have a shield around it and you'll close the door, because when the air is moving, it'll screw up if you're trying to be very precise. So we want to zero it out, and then salicylic acid is pure.
Excuse me, Dr. Russell.
Go ahead.
There are some people that are waiting to get into the Zoom.
I don't think do I have a waiting room set up?
I'm not sure. It just somebody said that they needed help getting in.
Yeah, the email should be a link straight into the meeting. So tell them to go to the announcements and click that link that I sent out yesterday, and it'll bring them straight in.
Okay, thank you.
Yeah, because I'm not able to send the password and all that stuff right now. So tell them to go back to the Blackboard, go to the announcements, click the link. Thank you for letting me know that too.
You're welcome.
That was kind of fluff. So it's gonna seem like it's a lot. Don't worry about it. 6.9 right. So everybody should write this number down. So we're gonna start with 6.9. Put that in the column on your data sheet that says, what does it say? I know one says actual.
This is
Yeah, and then we're gonna transfer that.
Aspirin molecular.
Actual, it says actual, and what else does it say? The other column.
Required amount.
Required. So 6.9 is the required amount. The actual may be different based on who's measuring. Right, so you have 5.3. So you don't want to put the exact same amount that you did last time, because that was about 3 grams. So now you have 6.915. That's good. What you need, that's why it's 2 columns on your data sheet, actual and required. So actual is 6.9, come on, balance 6.913. 2. Go 2. Because it keeps going back to 2 and stuff. So the way we're gonna do this, for those of you who are streaming, you pick a number. So we got 3 people here. There's gonna be 3 different masses that you can use for the actual amount. So the first mass, I'm gonna put it in the chat, is 6.912. And then whoever's going next, we'll put your number in there, and then we'll put the third number in there. All right, you good? So you're gonna take this. I'm trying not to put them on play. You messed up, man. You're gonna take this and transfer it. Go back to your old trap. I mean, man. All right, come on, go there. You can just hold on to that thing until
The terabyte is this one, right?
that's the one that says 0, yes. So y'all gonna tear it out and then go ahead and start adding before the wind blows. Ooh, no. Uh-oh.
Yeah.
Somebody, you standing right there and ain't paying attention. Oh, Lord.
I just said it backwards. I just said it.
Okay, I'll give you that. I'll give you that. Seven. 7.08. Second mass is 7.08. Again, you can pick which one you want to put in your actual column. And then you can go ahead and you want to drop. We ain't gonna drop that. I got company. I watch her drop everything to mess you up. So is it 7.08?
Yeah.
So while you're waiting, go ahead and put your water on the hot plate and, so it can be heating up. Which one you got put it on about, that one has temperatures on it. That's good. Put it on about 150. Just to get the water boiling, then we'll turn it back down.
Should I tell Tim?
No, I'm putting on 10. Put it on like 6. All right, perfect. All right, and then, so now you can go ahead and wear yours out. All right. Still recording. Yes. Can you imagine being in here with 60 people?
I bet not.
Right,
But it was always high lab.
I've been doing that for,
Dr. Russell,
yes,
are we filling out the data sheet?
yes, that's why I'm putting the masses in. You pick which one you want to work with.
Okay.
I'll put the third one in once Anaya is done wearing out her stuff. And we're waiting on these water baths to heat up. I'll be
I
nervous.
was in your lab last year. You probably don't know.
And which one? My G killer?
Yep.
Really?
Yeah.
What's your name?
Victoria Baker.
I do remember you. I do. I remember your name, but you know with Zoom, you don't never see a person. You
Yeah,
just
this
see.
is my first time coming in on it. And I'm hold you.
That's all right. First time for everything. What's up, Dr. Guy? What you do? Just checking in. Just messing around, trying to make it a little nasty.
Tell Dr. Guy Shakari says, hey.
He can hear you. He said, hey.
You don't know you Shakari. I see it on his screen.
Back, you like, okay.
No, hey, for real though, what we're gonna do the next time, we gotta have a camera day. So everybody next week, just plan to show your face. So comb your hair, put some clothes, put a shirt on. Cause it's hard, like, getting to know people when all you see is their name on the black screen. That's hard.
Dr. Russell.
Or, so we're gonna do 3 sig figs. Okay. Thank you, Margaret. Oh, Margaret. What is it? 6194? Yeah, we're gonna do 3 sig figs for these masses. So, but you can use the mass that you got if you're here. So 7.02, 6.94, and then 6.91.
So actual mass, that's
7.02. All right, everybody good so far? We got good participation. We got 39 people logged in. That's good. I think it's really like 50 people in this class though, 52 actually. So 13 people didn't get the memo.
Dr. Russell.
Yes.
Like for like in-person classes, do we have to sign up to come? Because I know some labs they make you like sign up in order to come so they know because of COVID. Or do we just
No. When I send out the announcement for the next lab, I'll do it at random. That's why I did that survey to know who was on ground and who was virtual.
Okay, I was asking because I'm not in any group. Like I'm new to the class, so I'm not in a group any groups that you assign, and I don't know if that's how you doing the
No. Okay, so I sent out a survey. I'll send it to you. If you're on ground, you'll be in the pool at some point to come in person. I just picked the names at random, but
Okay,
there's no lab groups.
okay, thank you.
Yeah, no problem. You know why? Because you're like one of the only guys in the class. Okay, I had to try to mix it up. But, you know, these like that. All right. What we're gonna do now is 2 things. It calls for the second step with the acetic anhydride calls for you to cool this down, but the amount of sulfuric acid that we're adding is so little that we're not worried about it. Normally, if you're adding a catalyst like that, you want to do it on an ice bath because that's an exothermic reaction. And if you got a lot of reagent, and you add that acid, it can be out of control. So, but we're not going to worry about cooling it because we're only going to add a few drops of sulfuric acid to a small amount. So we're going to add let me get that acid. We're gonna add the acetic anhydride and sulfuric acid at the same time. All right, so this is sulfuric acid is one of the reasons why you never come in lab with sandals on. If this stuff gets on your skin, enough of it, it'll go through to the bone. It's that potent. All right, let me get move the camera. So we're gonna take and for those of you who might have missed this part, we're cutting every reagent in half. So we started with 13 mils I'm sorry, 13.8 grams of salicylic acid in the procedure, but we actually only added 6.9. So we're also going to cut the amount of acetic anhydride from 14 milliliters, which was the actual. We're going to cut that to 7 milliliters. All right. So I have a little syringe here that I'm going to use. And so because we want to be accurate, we don't want to just hold stuff in. Chemistry, one of the things about chemistry is accuracy. You want to be accurate. You don't want to just be willy-nilly with stuff. That's how you get blown up. Could I have picked a pen or needle? I gotta go Rambo on this one. Hold up. And for those in person, you can probably smell that acetic anhydride. It probably smells a little bit like vinegar. And that's because when it decomposes, when it reacts with the water and the air, one of the things you get is acetic acid, which is vinegar. All right, so I'm gonna put this here. Can y'all see that? Yep. I'm gonna add that. I need to add 1 more milliliter because that was only 6. So that's 7 mils of acetic anhydride. And you can see that's not dissolved, right? That's not in any way dissolved. You still see the salicylic acid in there as a solid. All right, so the only way this is gonna react is if you heat it up. So that's the purpose of the water bath. So hopefully these are, all right, so once I add the acetic anhydride, I'm also gonna add a few drops of sulfuric acid. The reason I know this is sulfuric acid is because this is the same card I used last semester. So I'm adding 6 drops of sulfuric acid. Again, normally that step will be done on an ice bath, but it's such a small amount and everything is cut in half, so we don't have to worry about that step. So take that, sit it in there and swirl it. All right, I'm gonna come around to everybody else. So just hold tight. Anybody got any questions before I go to the next bench? Anybody? You'll see we got 2 other participants in here too. So but only one of them speaking. So we're gonna do something back here. We're gonna take this. And if you want to turn that water bath to heat up a little bit, you can. I'm not sure how close it is to boil it, but you don't want it boiling, you just want it hot.
Dr. Russell, are we supposed to be seeing what you're doing or we're just listening right now?
Well, no, I had the camera on the first one that I did, and I'm just doing the other 2 people that's in here. That's all.
The camera isn't where his name is. The camera is on another screen.
It should be pinned. Is it not
over-
pinned? Albert's iPad? It's not pinned?
It's not pinned because I had to slide it on my phone to
Hold
find
on,
it.
let me
You can pin it yourself,
let me
though.
pin it. Albert's iPad. It's pinned on mine. Oh, that's the problem.
Tell them the name of
They
it.
can
pin it themselves. Just gotta find it.
Yeah,
It's
just
supposed to be
if you
clear
find,
on
yeah, it should be. Hold up, this is good stuff. I gotta move this. So those of you who are streaming, can you see my iPad? Just look for Albert's iPad and pin it. Because we got so many people logged in.
I got it. Thank you.
So just pin the iPad. Hold that up real quick. See how that's going clear? That's what you want. So keep heating it. We're coming and we're gonna come around and make sure that everybody else is moving. And once it goes clear, you can set a timer for 5 minutes and run it and heat it up for another 5 minutes after that. So one more milliliter. Start heating that up. That's about it.
Can I stop now?
Within 5 minutes.
Oh, I gotta keep swirling it for 5 minutes.
You don't have to keep swirling. Once it goes clear, you can just let
Oh,
it
okay,
sit.
that's what I was asking. So let it sit.
Yeah, let it sit in here
Oh, let it
for an
sit.
additional 5 minutes.
Oh, okay. It's supposed to-
That's the, you don't want it to touch the bottom, but then it's gonna overheat. That's why we use the water as a buffer between the hot plate and the actual plate. You can turn this down. Yeah, you can smell that. You're gonna smell that acetic acid coming off, because that's one of the side products. And it's a pretty fast reaction too. All right, so everybody who's streaming, you should be able to see. I should get a Oscar for all this videography I'm doing. But you can see how this went clear. It was all solid at first, and now it's going clear. So you want to keep heating that for another 5 minutes, and then we'll take it off. We're gonna add water, and then stick it on an ice bath and let it crystallize. Where's my distilled water?
So it's the acetic acid and what else?
This is acetic acid. Swirl that around, get that solid on the side. That down in there. Water right here, put it forward.
How does it look like?
Got a leak, and you take that out. That's what I was talking about. If it's too cool, then it'll solidify before it's supposed to. So just let it sit for a second. I'm gonna turn the heat up a little bit. And then when you see it start to dissolve a little bit,
Okay.
but sometimes again, if it cools too quickly, it'll solidify like this.
Okay.
That's what I was talking about at the beginning.
Mhm.
But it's fixing. It's not a fatal error. It'll, we can fix that. Anybody have any questions? If you're streaming,
I have a question.
go ahead.
So what are we supposed to do with the masses that you gave? The three
You can
different ones?
Pick one and put it in the column that says actual for salicylic acid.
Okay.
And then we added 7 milliliters of acetic anhydride. So put that in the actual column too.
Okay.
You said 7 milliliters of
7
what?
milliliters of acetic anhydride.
Under which section?
There should be a line that says acetic anhydride, right?
No, I'm saying which tab for the acetic and hydride.
Oh, you can put both actual and required.
Thank you.
Mhm. Oh,
So just to be sure, we're only supposed to have the actual amount for the first acid and then the required and actual amount for the acetic anhydride.
Oh, actually, don't, just take that out. Say that one more time. I was out in the hallway.
We're only supposed to have down the actual amount for the first acid and then the required and actual amount for the aesthetic, what is
And
it?
hydride, yes,
Yeah, okay, it's 7 milliliters.
7 milliliters, yes.
Okay.
Let me have yours, tonight. We got, your hot plate might be, the problem. We're gonna put it over here. This is already boiling. Always more than one way to skin a cat. Always remember that.
You want me to twirl?
You just want to- Go ahead. Go on, twirl it, child. You want me to? I asked you. Go ahead. You got the Midas touch because yours did what it's supposed to do. So go ahead. Yeah, you do. You got it. While we're doing that, go ahead and jump out. You already time for 5 minutes. Yeah. Go ahead and jump out the water. We're gonna turn that into a hydro. Take that, put up water that's in there. We'll put some place in there. These are tempered glass so they won't crack. They can go from cold out. Got it. Go ahead and put a little bit of water in there about once a year. Is it going clear?
It is, but it's a big solid piece.
That's all right. Keep swirling. Midas touch. Does it have, is
Oh,
that
it's breaking
stuff
up.
stuck to the side too? Is anything stuck to the side?
No. Oh, something like that.
Yeah, let's see if we can get that too. So if you have if it's stuck to the side like that, normally I'll just turn it like that. Try to get all that stuff off the side, because all of that matters. High aspirin matters. Just leave it. Yeah, let that cool to room temperature, and then we're gonna add, anybody got the procedure printed out or pulled up, downloaded? How much water are we adding? Is it 40 mils? The whole thing. What we got over there? Wait.
Me? Oh, yep, it's breaking down now. It's going away.
What is that? There. All right, so we got
All good.
come on up now. Go on the floor. We got most of it in, but we want to get all of it in. We'll just heat it for, we'll just heat it and let it keep heating. All right, so the next step, we got two, oh, yours already turned solid. Wow. Yeah, so we got two more things to do. We gotta add water, and that's okay. We gotta purify it anyway, so it's fine. We're gonna add water, but it's gotta be cold, distilled water. So I got some water chilling over here. like Coronas in the cooler without Snoop though. All I need on is my smoking jacket, and then I'll, never mind. All right, so we're gonna add that cold water here. So go ahead and add that straight to your aspirin. You're gonna see it cloud up. So it turn cloudy. All
Oh, that's
it's that acetic acid. So when that turned cloudy, that's good because aspirin itself is not soluble in water. So when she added the water, what that did is it caused the aspirin itself to precipitate out, right? You don't want it to crash, but you want it to precipitate. If it crashes out, then it's gonna bring out kind of crap with it. So that's why you let it cool to room temperature first. So we're gonna do the same thing back here with Abraham. Yeah, that's what acetic acid is. That's what you smell it.
Yeah.
It's the leftover. So we do the same thing back here with Abraham sample. We already solidified, we still add the water. And we got an ice bath set up right here. So an ice bath, we're gonna take that, sit in an ice bath. Right, so tonight, we're gonna take yours off now. But we gotta let yours cool down to room temperature first. Right, so that's that. You see all that's going in. Anything that's on the side, I could take a glass rod and try to get it all in solution, but losing a couple of milligrams is not gonna kill us because we started with like 7 grams of salicylic acid. So I'm just gonna sit this right here on your bench top. And then your water is right there, and you can take, we gotta make your ice there. You see the aspirin floating on top? Can y'all see those crystals floating on top? That's crude aspirin. That's floating right on the top. And the thing about this, if we just left it at room temperature, it wouldn't do much. But if we put it on an ice valve, as the temperature drops, it's gonna cause the aspirin to precipitate out more. So that's why we're gonna set that up on an ice valve. So I'm gonna take this how we improvise, take the same water you made the ramen noodles in, cook your hot dogs in. All right? With water you want to get cussed out. So we're gonna add ice to that. Yeah. And you can go ahead and sit that down in ice bath. Mm-hmm. You already added the water?
Mhm.
Okay. Yeah, just sit it down in there. You'll see in a minute, the colder that gets, the more crystals you're gonna see come precipitate out, which is good. All right. I think Abraham, with yours, we just started, it was already crystallized. We just won't break it up. So, be right back.
What's the classification? I'm in science. What happened, sir? Oh, animal science junior. Did you just say you're a senior? Yeah, I'm three credits shy of being a senior. Oh, shit, that makes sense. But you just got here, right? Yeah, this is my second year. I was about to say because I graduated my associates in high school. Oh, that's what it is. So then I'm like here. I was so like senior. Yeah, I haven't really experienced both of these. Exactly. I haven't experienced none of this. I barely experienced SED. My freshman year, first semester, I'm a junior. So we had homecoming and stuff, and right after homecoming, they sent us home. Look, now we have-
Oh,
All right, let me see what we're working with here. You can see that now, there's a lot more crystals in there than there was when it first started. So the longer you let it sit, the more crystals you're gonna get out of solution. And let's go around. This is another sample. You can see the same thing. Hers is almost solid already. That's good. Yep. And then with Abraham sample right here, same thing. We've already had started solidifying. So the next step is to do the filtration. And we gotta set that up. So we need a vacuum flask, we need a rubber hose, and we need a Buchner funnel. All right, so a Buchner funnel looks like this. So it's just a conical shaped funnel, it's plastic. And we're gonna put a piece of filter paper down in there and set it up using a vacuum filtration apparatus. So let me get everybody a vacuum flask. Hold it.
I'm so sorry.
Really cracking, man.
I need to talk about this. Yeah. We are.
You don't still have the goggles for Deacon when you want to move?
We were virtual.
Yeah,
Where
we're
are we
virtual.
going for?
Yeah, true. All right. Get it.
I mean, like, I can't buy something like this. I got to look at you.
I know folks bought her Apple Watches with boot
No, my
vouchers.
friend just bought her iPad, and I was like, why ain't you do that?
Should have thought of it.
I'm gonna do it next semester with your ring.
All right, so this is a vacuum flask. You can see the little nipple on the side. You're gonna connect that to the aspirator on the sink, which is over here. It has a little nipple coming off of it. So we're gonna connect the two, and when we turn the water on, it's gonna create pressure and create a vacuum. Under normal circumstances, we use a different type of funnel called a fritted funnel, but this is cheaper and it's easier to set up. So we're gonna use that. So I need to get this prepped up because sometimes you have to wet it in order for those the tube to fit over. It's kind of burn you up. Right, same thing on the vacuum flask. That, man. That's set up. So then we need a filter adapter, which is here. And if it won't fit inside the hole, you can just turn it upside down, and that works too. Because what you're trying to do is create a vacuum. So you can sit your funnel on top of that like that, put the filter paper in. You can wet it if you choose to, and then filter. All right. So you need that. Huh? Mhm. And you probably had the same problem with the tube. You gotta wet that the little pin on both of them. Never have enough food. And you need a filter adapter. You're gonna use that one instead. Is it solid all the way?
No.
Also? But now
Yeah, it's close.
Pour it all up.
No, I'm not. Mm-hmm. Yeah, everything. Yeah, I forgot my bubble shirt on my sister, so. I'm talking about one in-person class last time. This class was the worst. I did it.
You said this is the worst.
I said this one is the worst. I had got my first year. I had visual arts shirt. I had God's for Kim one. I had visual arts for Kim two. You took God's for Kim too? I just had to take the lab again. Oh, because you already took that class. Yeah, I took the lab. Oh, yeah. No, I'm talking about the class. Once you guys that class was terrible. I think I had God's for lab. No, I had Russell for lab. Last year. So we gotta get some. Oh, okay. Yeah, tell us what you want. Oh, you're outside there too? Yeah.
I was the first person to say it.
Oh, I'm sorry. I want that.
I forgot the name. What was it?
Tonight. You can call me now. And I got back here and so we're not really. I mean, I don't be paying attention.
Yeah, I'm about to say, you wasn't really paying attention.
All right. I think we're ready to filter. So sit that down in the phone. Feed it. There you go. Yep. And then so with the filtration part, whatever we don't get out on the first try, we can add more water, swirl it around and get, because we want as much as possible. We want to get everything. So if it's solid like that, I was looking for a glass rod. I thought we had some. Obviously we don't. But you can use the end of the scoop and just crush it up with the other. Never mind. So, go ahead, y'all. You don't be listening.
Crush the filter.
Yeah, no. The aspirin.
Oh.
We need to get it to where it'll come out.
I feel like the
So take your.
outside would be good.
Take your food. Yeah. You want to put that out. Right. So once we need this, we need the crystals to be actually loose, right? So we can filter it. That should be good right there. Now what we're gonna do is after the filtration, we're gonna rinse that. I got it. All right, so go ahead for it. Pat it. You can see that water is draining off. In that water, there's also acetic acid left over, so you want to get rid of as much of that as possible. And then if we need to rinse again, want to rinse like that.
That's a water in it.
20 mil, rinse 2 times, 20 mil. You got 40 in here. 420 in, swirl it around, rinse it, and then do that twice. All right, and you want to rinse it because any solid that's left, that's part of your product. And you want to keep as much of that as possible because you want the highest yield possible.
You
All right.
can rinse it out many times or what?
Twice, rinse it twice. Just add it, swirl it, and go.
Pour water recipes on it? I'm confused. No, I'm talking about the one earlier.
Oh, no, I think you got it.
Oh.
Yeah, I think it's for the school.
Well, water? Yeah. Yeah, he just poured that. That's how I was getting home. The dude looks like it's gonna come out, like he poured too much, like if you pour too much, it's gonna come out. So, like what's gonna come out? Like, I'm not sorry. But if you pour too much in there, like it's gonna overflow. What's gonna overflow? Crystals. No. Because it's all falling, the water falling to the bottom.
I think you only put like 2.
He only put 40 millimeters in water.
All right. All right, playing. I think that's good though. That's good. You want to be as thorough as possible. So yeah. Anybody have any questions about anything? Because after this point, it's just cleanup. So we're
Yes.
gonna stop the stream unless somebody has questions.
I do.
Go ahead.
How many milliliters of water did we add?
Okay, so we added 40. We added 40 mils of water. And then we rinsed 2 times with 20 mils each, so another 40 total.
So you did like 80 altogether?
80 total, yes.
So you say you added the cold water, and then you say you mixed it with cold water?
Yeah, cold distilled water, we added 40 milliliters.
Okay. Because I felt like I was missing something. I don't know.
Do you have it? You got it now though?
Yeah, I got it.
Okay, all right, cool. Yeah, you want it. Oh, that's all. Glad you got it on. I'm glad you got gloves on. This is something that I'm pretty adamant about, wearing gloves, but you don't want to. Yeah, the aspirin, what you'll find out when we get ready to purify it, based on how it looks before you start, you can already tell if it's a bad batch or a good batch. A good batch is going to be really shimmery and sparkly. A bad batch is going to be real dull and clumped together.
Like salt.
Worse than that. Like Epsom salt. Yeah, all clumped together. It'll look like that. All right. Nah, it ain't bad.
I wasn't looking at my extra stuff. I just got some on my gloves, and I thought my gloves were kind of tiny.
Clumped together like that, it's fine, because after it's dry, that's good. All right, so what we're gonna do is, after this filtration step, clean up. So, anybody have any other questions before we log out? Because
I have a
all we're
question.
doing now is cleaning up. Go ahead.
So are we supposed to report anything else besides what you already gave us?
No, on the next time we come, we're gonna do the recrystallization. So we'll get a crude mass, because this has to dry for a week before you can touch it again. And then we'll recrystallize it and get a pure mass, so we can get the percent yield and all that stuff.
Okay.
Yeah, so right now, if you got the reagent table filled in and the amounts, you're good.
Okay.
All right, any other questions?
Do we have anything to turn in for next lab?
Nope, we're not turning anything in until everything is filled out.
I have a question.
Go ahead.
I'm new to the class, and I saw that we have labsters, but when I tried to do one of them, it said it wouldn't be graded. Is it because it's not open to me?
No, it's still open. It's something going on with laughter. My suggestion is to open it back up, and when you get to the end, just take a screenshot of the last part of it
Okay.
and submit that, because there's something going on. You know, when you don't pay folks, I almost gonna say it, but when you don't, you know, laughter just went gangster on us. That's all. They want their money.
Okay.
So just do where you can get up to the end, and then just screenshot that.
Okay, and is there a due date for them?
Well, the laughters are past due, but since you just got in the class, it's fine. Just do them when you can.
Okay, thank you so much.
All right, yeah, you're welcome. Any other questions?
Yeah,
Are
I
we
did have
supposed-
one question about the actual amount for the sulfuric acid.
Yeah, just put 6 drops. It was only
Okay.
a catalytic amount.
All right, thank you.
Okay, I heard another question coming too.
Do you want us to do the nucleophile labster for this
No.
one?
No,
Okay.
I'll assign it, but it's not due. I'll send out an announcement when I want y'all to do that.
Okay.
All right.
I never got it.
You didn't get it?
Was it sent on email?
I don't know. You can go watch it now.
Okay.
Any other questions? All right, I'm gonna go ahead and log out, because everything we're doing here now is just clean up. Let me show you the app.
Did you say the number of moles?
You see the aspirin here, nice white solid, shimmery. So when that dries, we're gonna recrystallize it, and then we're gonna test it. Do all kind of tests on it to see how pure it is. All right. I think I heard somebody else asking a question.
Yeah, I was asking about the number of moles.
You got to calculate that.
Okay,
Yeah, so if you look up, that's why you have to look up the molecular weight and the density and all that stuff. That's what all that information is gonna help you calculate.
thank you.
But if you know the molecular weight is in grams per mole and you have a number of grams that you use, it's just grams over molecular weight. And that'll give you moles.
All right, thank you.
Mhm. All right. Anything else? All right.